now. Okay, so good morning, guys. It is Wednesday, May 27th. And what we're doing today is we're on our last module. And for those of you that weren't here last time, we started looking at the lymphatic, also known as the immune system. So this is the last module you'll have for this year. And it's a fitting module because this is kind of the reason why we're all online right now. It's immunity. So, great chapter to end with, a great module to talk about. And so I'm going to walk you through what the components for this module are. And as always, you can just rewatch the YouTube video in case you missed last class, but I'll just give you like a little brief summary. So as usual, these are my 5 folders. In your notes folder, you have my learning objectives, so you know what exactly we're going to cover. And then chapter 12 is, it's really 2 systems in one, but I'm combining it as one. And so that's why I'm calling it lymphatic, also known as the immune system. So this is where I'll be pulling the majority of the information that you're going to need for the quiz will be from this folder here. As usual, you have an assignment folder, which is your orange folder, and on what was it, Monday? Anyway, last time that we met, sorry, I'm losing track of my days, we watched a couple of videos that we discussed in Zoom group. So we watched one on the immune system, that was a TED Talk, and then we watched a brain pop video on the lymphatic system. So I'm combining both of these systems together. So since the 3 of you, I don't think we're here, anyone care to take a guess? Why am I lumping the immune and the lymphatic system together? Why do you think so, Daniel? What do these systems have to do with one another? Daniel?
Um, do they both work towards like aiding the body against like um, bacteria and stuff?
Yeah, I mean, yeah, pretty much. How about you, Fatima? What do you think? Why am I lumping both of these systems together? I mean, you probably haven't heard. Well, be honest, Fatima, have you heard of the lymphatic system? I don't think a lot of students have heard of this. Have you heard of the lymphatic system?
Not really.
Yeah, it's one of those that isn't really mentioned, and it's sad because it's so important. But the real reason you probably haven't heard of it, guys, is because it goes by another name, and that's the immune system. However, the immune system isn't really a system, and I'll show you what I mean by that. The lymphatic system is really a system, and so they kind of get jumbled together a lot, and for a lot of people they are the same thing. We're going to treat them as separately. That's why I have 2 separate videos. So you 3, please make sure you watch these videos. They will be on the quiz. And then I posted some discussion questions that we had last time when we met with the other students. Okay, so make sure you watch those. They're really short. They're like 5 minutes each. But as always, you have a watching assignment, which is your final crash course on the lymphatic. And then you're going to do a reading Newsella assignment on the immune. So again, they are different, but I'm lumping them together. And it's kind of, connecting to what Daniel said, they do help to, fight off infections, and I'll show you what I mean by that. But they are 2 different things. And so that's why I'm having you watch 2 different videos and watch and read 2 different assignments here. Okay, one is going to be, again, a crash course video, which I've linked here, and one is going to be a Newsella article. Any questions about that, guys?
No.
Okay, cool. All right, so that's your assignments. Your quiz I have put for June 3rd, so that's next Wednesday. I may push that back to next Friday, honestly, because we lost Monday due to the holiday, so I don't think I can cover all of this in, let's see, today's Wednesday, Friday, Monday. Yeah, that's kind of short. So I may push this quiz back to June 5th. But as always, if you want to get a head start and you think you're ready for it, just message me and I'll turn it on. But I have that for June 3rd. The discussion board is going to be interesting. And so like I said at the beginning of this class, the reason why I'm kind of glad that I saved this one for last is in lieu of like what our situation in the world is right now, and that's COVID-19 pandemic. So let's go ahead and look at this. Scarlett, would you mind reading us, please, this discussion board assignment?
After having watched the PBS video, students will answer the essential questions. Are we in this together? Why or why not? Provide at least one piece of evidence from the video or from your own experience. Then comment, react, debate, question, opinionate, discuss concerns they have about the issue by responding to at least two other students' answers.
Yeah, and so thank you, Scarlett. And the video I linked right here, and it's a pretty interesting video that I found, and I thought it was really relevant to everyone, really, because if you aren't aware, states have lifted restrictions on lots of things, right? So parks are open, beaches are open. A couple of states did that a long time ago. They did that a few weeks ago, and here in California, just last week, we reopened our beaches, parks. Even national parks are open now. So I found lots of articles on that I thought were pretty cool that I was going to share with you guys to read. But I thought this little video was more interesting. So this video is about people of color, and something that I think is kind of neglected in news coverage is what's happening to people, and what pattern is occurring as far as who's being affected. So without giving away too much, I'm going to let you watch that video on your own. And like Scarlett said, like the essential question I'm asking you guys is, are we really all in this together? And I think I'm going to change that to, are we all in this together? Okay, rather than just, are we in this together? Because I'm trying to make a point here, and I think you guys will get it. You guys are all smart. But it's kind of like an issue that has not become, like black and white anymore. It's kind of like this gray area of it's become political now. This whole outbreak has become political. Who's making decisions has become political. Who it's impacting has become political. Economically, it's become political, and it's become racial. In case you guys aren't aware of that, do you know what I mean by that? Have they discussed this in any of your classes, guys?
Not really.
Not really. Yeah, that's what I thought. So, um, you guys have government, right, Fatima and Daniel?
Yeah, but she doesn't, well, my teacher doesn't talk about anything.
Oh,
Yeah, she hasn't went over that.
oh no. Okay. So, let me tell you what's happening here. Okay. So, obviously, there's a lot of controversy with our government, right? And a lot of people are upset about the fact that the U.S. reacted so late. And so that's why on March 13th, they just said, whoa, stop everything, send students home. We need to do something quickly so that we don't expose students, right? So that's the world we live in now, right? The world just stopped. LA Unified stopped March 13th. And a lot of people blamed the president for reacting late. But then there are people now who are kind of making it more of not just a political thing in terms of like who's a Republican, who's a Democrat, who's conservative, who's liberal, but now they're turning it into something racial, because now it's like, if the government is now trying to open businesses, who does that benefit? Who do you think benefits from that if they start just opening all of these businesses like they've been doing? Who do you think profits from that? Who profits from that? Like, why do you think there's such a rush to open up businesses, guys? Is it because everyone is craving McDonald's, or like, why do you think they're doing this?
Because of the economy.
That's the economy, Scarlett. But who do you think benefits from this?
The government.
The rich.
The rich. Yeah, it all comes down to what they call, the 1%. So by opening all these restaurants, and if you're also not aware, the government is trying to bail out restaurants and trying to bail out industries that are losing money, meaning they want to give money to those people. And who profits from that? The uber rich profit from that. And who does not profit from that? The poor.
Us.
Us, right? And as a whole, obviously the people that are kind of the more impoverished are usually people of color. So this video that I want you to watch,
George.
titled "Why is the Coronavirus Hitting People So Hard?" covers that. It covers like who's really being impacted here. Are we in this all together? Are all ethnic groups really affected by this in the same way? And you'll find that surprisingly the answer is no. And I'm not just talking in terms of money, okay? Because if you go to a lot of businesses that didn't close, and people that were still employed and that continued to be at work, you'll find in this video the pattern that it happens to be people of color, and they're the people that aren't really given the same health care, the same type of safeguards that other people are given. And it's something that really bothered me when I watched this video, and I was like, oh man, this is something that I think all of our students need to be aware of. So it's a good video. It's short, but like Scarlett said, the essential question, the thing that I really want you guys to discuss is, are we really all in this together? And I do mean, and I'm not like trying to use like slurs. It was called people of color. I don't like that term, but that's what the video is called. So you're going to watch that short video. It's linked right here. And then as usual, comment here. And this one should be a juicy conversation because this is a really controversial topic, is like, who's benefiting from all this? Who's being hurt by COVID-19? And I don't mean like who's dying per se. I mean like who's suffering from this. And that video is just, the tip of the iceberg, because obviously there's a lot more things to talk about. So like Scarlett said, yes, I would like you to include at least one piece of evidence, but I'm going to change it to one piece of evidence from the video and then one personal experience, because I guarantee all of you, including myself, we are all being affected by this in ways that you probably aren't aware of. And so, Fatima, I would ask your government teacher, I would ask her or him, whoever it is. That's Maurerman, right?
Yeah.
I would ask her, like, hey, like, what's the political climate of COVID-19? Who is benefiting? Who's being hurt? Because it's not black and white anymore. And there are lots of things that aren't really being discussed in terms of, I mean, there's even, some conspiracy theorists, which I don't jump on that bandwagon, but there's some people that are saying, obviously, that, and I think I told you guys, a lot of people are claiming that this was planned, that this was something that the government set up. And I'm not going to get into any of that. And I don't want your government teacher to either. But what is important to discuss, I think, is who is being affected by this. And you hear this and you've seen the hashtag. You've seen the hashtag, right? In this together. It's all over the social media. You've seen this, right? In this together, the hashtag.
Yeah.
Yeah. So it's out there, right? And if you look at those pictures and then you watch this video, you should come to a realization that maybe we're not all in this together, at least not in the way that they want us to think. So I'm really looking forward to what you guys have to say on this discussion board. It's going to be a little different than previous discussion boards, because it's not really about the chapter per se. It's more about like the political climate of COVID-19. So I don't know. I thought it was pretty cool. So that's going to be your discussion board. All right. Any questions about that? Okay. And our summative assessment, like I was telling my seniors, next week, let's see, June 1st through the June 8th, normally is supposed to be what we call the stop week, where senior grades are supposed to be due by June 5th, because the week of June 8th through the 12th, seniors, let's see, we got Fatima, Daniel, Daisy. You know your schedule, right, Daisy? You know that you have to come get your cap and gown and take your picture. You're aware of your schedule?
Yes.
Okay, so that's what I was telling Daniel and Fatima before you guys got here, is the week of June 8th through June 12th, I'm going to take it easy on seniors because, like, you have bigger fish to fry. You have to worry about graduation. You have to worry about what you're going to put on your cap, and you have to worry about, and I'm not trying to stress you out with work. So for me, like I had told Daisy the other day, June 5th is going to be the day of that quiz that I was saying, and then whatever the summative assessment may be, I'm going to make it like a little bit light. I'm not going to make some like huge thing, and I'm definitely not going to have a final exam per se, but we will have some assignment that'll be due, but it won't be the last day of school. So the last day of school is June 12th, and so this summative assessment, whatever I decide it to be, I'll probably make it due like June 8th or something. That way seniors have the entire week just to get ready and prepare for the graduation. Sound like a plan?
Yes.
Okay, cool. All right, so that assignment is still pending. I haven't decided on it yet. So let's go ahead and take a look at the notes so we know where we are, okay? So like I had just said before we started, this is the last module. And this module covers the lymphatic and the immune system, which are kind of lumped together. And the reason is, like Daniel told us, is because they kind of do the same thing, but they're not the same thing. So can you read us, Daniel, this entire slide so we can talk about it? Daniel, can you read us this slide?
The lymphatic system is a system of vessels, cells, and organs responsible for fighting infection and controlling fluid levels in tissue. The immune system is a system of cells and organs that destroys pathogens.
Yeah, so their functions kind of sound the same, right? The only real difference between the two, according to my notes, is what then, Daniel? What's the real difference here?
Um, the immune system destroys them. Or wait.
Yeah, they both do that to an extent, but you can see here the lymphatic system has vessels, and vessels is another word for tube. Okay, so the lymphatic system is essentially just a system of tubes that circulates fluids throughout tissues. And Anna, do you remember what that fluid that circulates through the lymphatic system is called? We saw that video the other day.
The plasma
It's known as plasma,
or
but
the
then
lymph.
thank you. It's called lymph, right?
Okay.
So very good. Thank you. So an example of how both of these systems would work together would be like this. So on last time we met, we watched the video about, and I think it was you, Anna, that asked the question about tonsils, right?
Yeah.
Yeah. Okay. So your tonsils, Daniel, Scarlett, and Fatima, if you're not aware, are they're basically found like at the base of your mandible. Okay, and they're these little organs that technically are known as lymph nodes. A lymph node is essentially like a filtration unit, and they're located throughout your body. So the ones that are located nearest to your ears, your eyes, your nose, and your mouth are called the tonsils. And I think Daisy was the one that addressed this. Why did we say, Daisy, that the tonsils are the first thing that swell up when you're sick?
Because that's where most of them are just like located.
Exactly, right? And that's where all things enter. That's where dust, pollen, bacteria, viruses, they all kind of enter basically in your head, right? And so the first sign of infection, the first thing that swells up, the first lymph node, which is the tonsils are a lymph node, which again is like a filtration unit. That's the first thing that swells up because, again, that's where everything enters, right? So the way these two systems work together is like if that lymph node swells up during an infection, these things called lymphocytes, which we'll talk about, it's another word for like a white blood cell, it travels through the vessels or the tubes of the lymphatic system. Okay, and so that's how those two systems work together. The lymphocyte is an immune system cell. The lymph nodes and the lymph vessels are the ways that those white blood cells get to the site of infection. Does that make sense?
Yes.
I'll say it again, right? So two systems, okay? The immune system is the cells, and I'll go back here, okay? The immune system is the cells and organs, okay? So an example of a cell I'm talking about for this slide, an example of that cell is a lymphocyte, which is a white blood cell, and you've heard of that term, okay? So a lymphocyte is fancy talk for an example of a white blood cell. So that's the cell of the immune system, okay? But the lymph node belongs to the lymphatic system. Okay, the lymph node, example, tonsils, belong to the lymphatic system. So they swell up, right? They swell up when I'm sick. The white blood cell, which belongs to the immune system, responds and sends these little white blood cells through the lymphatic vessels, which belong to the lymphatic system, right? So I get sick, my white blood cell immune system sends the response team to that site of infection via the vessels we call lymph vessels. Does that make sense, guys?
Yes.
Okay, that would be an example of how they work together. All right, so here is a picture of the lymphatic system, okay? And as you can see here, the lymphatic system is a system of vessels or tubes, right? And so I was telling Daisy and Anna the other day, remember that dummy, that little mannequin thing that I had in the back of the room? If you got a chance to look at it, there were these little green tubes throughout that model. Those are the lymph vessels, guys. And as you can see here, these lymph vessels, they kind of look like systems of veins, right? They travel all throughout your body for the most part, right? You can see they travel along the arm, they travel along the abdomen, they travel along the legs. And like I said, there are organs that belong to the immune system that are also a part of this system. An example of that would be the thymus, right? The thymus, which is located on the heart. But then we have this system, this organ that belongs to the lymphatic system known as the spleen, which also works together. Okay, so you have your tonsils up here, you have your thymus here, you have your spleen, which is the largest organ in the system. And what they do is they circulate this fluid we call lymph all throughout your body. And what lymph does, guys, it's kind of like the cleanup crew, right? Or the garbage disposal, right? We talked about this, Anna. It's like the cleanup crew. What it does is it'll travel to the tissue. So let's say it comes down to your digestive system, right? It travels to this area and it takes with it the things that you don't need so that they can be flushed out. So in that sense, that's why I called it. It's like a filtration system, right? So that's a picture of the lymphatic system, right? But the lymphatic system, like we said earlier, or Daniel read us earlier, works together with different cells, organs, and vessels. So let's first talk about the cells, okay? Now, we already looked at blood when we looked at the circulatory system, but we need to talk about it more here because the blood works with the lymphatic system, and it actually is what transports nutrients that travel then through the lymphatic system vessels. So first, let's look at red blood cells. Okay, so red blood cells, I just put them RBC for short. Their technical name is erythrocytes. And what red blood cells do, you're probably aware of this because we talked about it in the circulatory and respiratory system, is they pick up oxygen, right? They pick up oxygen and they transport that oxygen to your tissues. But when they go to the tissues, they also pick up with them the waste that your tissues release, and then your lungs exhale that. So that should not be anything new, right? This is something we already looked at in the respiratory system. The reason I want to mention it here, though, is because there's different parts of blood, and the red blood cells, that's pretty much their function. But the white blood cells are very important, and that's what I want to talk about in detail today. Okay, but the red blood cells, their function is not really immunity. It doesn't really help for infection. I just wanted to mention it here because it's blood, and blood is a component of the lymphatic system. But I'll say it again, it doesn't really help you fight infection. However, what it does do for you is it has a protein that we call hemoglobin, which heme is Latin for iron, okay? And so iron is what gives red blood cells their red color. Now, here's why that's important, okay? Don't worry so much about this slide. Let me just tell you what this red word means. So a reticulocyte is what we call like a developing red blood cell. And we use a reticulocyte count, or the doctors use this in their office to determine the rate at which your body is producing blood, because blood is made in your bone marrow, guys. And so if you have a low reticulocyte count, what that indicates to doctors is that you probably are producing low levels of red blood cells, and that can lead to things like anemia, for example, right? And so if you're not aware, anemia is basically an iron deficiency. And this is one of the ways that doctors can indicate that, right? So that's an unrelated health problem, but it is still technically a lymphatic pathology. Oh, so this one's just some fun facts. You don't have to worry about this. Males, we produce more red blood cells, and we typically have more red blood cells than females. Can anyone think of any reasons why that is? Why would males have more red blood cells? Think about it. Why would males have more red blood cells? How about Anna?
I'm not sure.
Okay, what do you think, Fatima? Why would males have more red blood cells?
Is it because they're generally bigger?
Yeah, it has to do with mass, especially muscle mass. And that's just nature. I'm not saying there's not females that are way buffer than I am, but generally males have more muscle mass, and so they need more more blood to maintain oxygen supplies to those muscles, right? But again, this is not being sexist. Of course, there are males that have less muscle and less red blood cells, but the other reason is because of ovulation, menstruation. Females lose red blood cells monthly, right? That's what your menstrual cycle is, but that's the other reason. Okay, let me just say briefly about blood types. Don't worry about this, not too important. I just wanted to say this. The other things that we use red blood cells for, though, is to determine your blood type. There are 3 blood proteins that exist on your surface of your red blood cells. They're known as the AB, which you're familiar with. And the ABs, they work like this, okay? So let's say, well, actually, does anyone in this class know what their blood type is? Nobody?
No.
No,
You,
but
you
we
don't know?
should.
You should.
I think I'm A.
You think
I
you're A.
think I'm A.
Let me
Yeah.
tell you why you should absolutely know this, okay? On the surface of every single one of your red blood cells, every single one, you inherit genetically from your parents a surface protein. And a surface protein, I'm going to use my phone as an analogy. Okay, a surface protein is essentially what it sounds like. It's a little marker or indicator on the top of that cell that acts like an indicator. It lets other cells like it know, hey, I'm like you. So Scarlett, if you're a type A, okay, if you're a type A, all of your red blood cells, which again, females have about 4.8 million, um, every single one of them per milliliter, um, every single one of those, Scarlett, has that little protein that tells another neighboring red blood cell, hey, I'm like you, okay? What that has to do with the immune system. Let's say, for example, in the future, Scarlett, you were to have a child, okay? And the blood type of the father is different than yours. Okay, let's say that person's blood type is type B. There's a couple of things that could happen here, okay? So the way that A and B work, they're what we call codominant, meaning A doesn't overpower B, B doesn't overpower A. So if you're type A, Scarlett, that person is type B, your baby would be AB, okay? However, there is something that occurs that is very rare, but is very real. And that is your own body's immune system. If you were to get pregnant and that baby's blood does not match your baby's blood, guess what your immune system does to that unborn child?
It attacks it.
It kills it. Look it up. It kills it. And what ends up happening is because your blood, although, it's generally just used to circulate oxygen, it uses the ABO blood group as a way to recognize itself. And if the blood of the baby doesn't match the blood of the mother's own immune system can kill the first child. But get this, what can then happen is for the second birth, your body kind of builds like a resistance to knowing, hey, those babies are cool, let's not kill them. And it doesn't happen anymore. It's fascinating. Now, type O is different. Type O is what we refer to as the universal donor, because a type O means they have no surface proteins on their red blood cells, meaning, and actually I'm a type O. If this is my blood cell, guys, I don't have anything on my blood. There's no A's, there's no B's, there's no AB's, there's nothing. So guess what happens if Scarlett, let's say you're type A, right? If you're dying and you need a blood transfusion, do you think you can accept my blood?
Yes.
You
Yeah.
can. You can. And the
It's
reason,
universal.
say it again.
Universal. It's a universal.
Yeah, it's because I'm universal, meaning my blood, guys, your body doesn't recognize as foreign. So my blood is actually, the reason we call it a universal donor is because I can donate blood to a type A, to a type B, and a type AB, and their own body's immune system doesn't recognize it's foreign. So you can actually accept that blood. But guess what would happen if Scarlett were to give me blood? Guess what would happen?
Would you get like weaker?
No, so my body would actually reject your blood. And so before we understood the ABO blood group system, guys, before there was modern medicine, a lot of people would die of blood transfusions that were done incorrectly if the blood types didn't mismatch or if they didn't match correctly. Isn't that fascinating? So Scarlett, if you're a type A for real, type A's are actually they're kind of rare. I'm very common. Like my blood is the most common universal blood on this planet. Um, so type O's, we can save your life someday, but type A's, they're not, and so that's why it is important to talk about blood here. The other surface protein is called the D, and the D is what gives you that whole positive or negative. So Scarlett, do you know if you're a type A positive or type A negative?
I think I'm positive.
Okay, and so what the D indicates, it's another protein. It doesn't say positive or negative on the surface. It's just another variation of it. And so we just call them positive or negative. So I happen to be O negative. And again, it has to do with compatibility. So that's what we use the red blood cell for, is to indicate blood type. So anyway, that's pretty cool about red blood cells. Okay, I'm going to pause right here because I just saw the time. But blood. This is why blood is so important. Like I said, red blood cells, generally, their main function is to circulate, nutrients, get rid of waste, and it lets us know what your blood type is. But white blood cells, they are the heroes of the lymphatic and the immune system. They're the heroes in that, well, first of all, they have another name. They're called leukocytes, okay? And what they do, like Daniel said, is they help us fight infection. And They're not as common as red blood cells. Like you saw, there's a ton of blood cells that us males have. White blood cells are less common, okay? And they're less common because we need them to be. Imagine this. Well, think about this. Think about how medicine works, right? If you take antibiotics all the time, what do you think would happen to you? If I were to take antibiotics every day, like if it was a vitamin, what do you think would happen to me?
Your immune system will be dependent on them.
Not quite, Fatima, but good guess. So let's think about, what do antibiotics do from your personal experience before I get into what antibiotics are. What do you guys think
Don't
antibiotics do?
don't they fight off like pain or like allergies?
Not quite, Scarlett, but you're getting there. Does anyone know what antibiotics do? Doesn't fight off pain.
Do they produce more like white blood cells?
Not well, not quite. Let me explain. So, antibiotics are made by a type of white blood cell we call a lymphocyte, which I'm going to get to. Okay, what they do is they're hunters. They target a specific infection. So again, if I take antibiotics every single day, what do you think would or would not happen? Again, antibiotics target a specific infection. If I take one antibiotic every single day, what do you think would happen to me or would not happen to me? Come on,
It
guys,
would
think critically.
kill it.
Say it.
It would kill it.
Not quite. Again, antibiotics target one infection. That's why there's so many different types of antibiotics you can buy over the counter. Let's say I just take one, like one that I get from my local store that's cheap. I take the same one every single day. What would or would not happen? Come on, guys, think critically. Daisy, what do you think would or would not happen?
I think you wouldn't get that infection.
No, antibiotics are not. I think you're confusing antibiotics with vaccines. That's not that. What antibiotics do, like I said, is they target one thing. So let's say I take the same antibiotic every single day that's meant to, like, I don't know, kill off a certain bacterial infection I have, like in my tooth, okay? And I take just that every single day. What ends up happening is bacteria mutates very, very quickly. And you may know this when your doctor tells you take the whole dosage for 1 week or 2 weeks, or else you'll get sick all over again. It's because all it takes is for one mutated bacteria or virus to change its DNA sequence, and no longer does that antibiotic work for it anymore. So if you take the same antibiotic every single day, chances are that bacteria is going to mutate and it will no longer be effective. That's one thing that can happen, is it will no longer be effective. But the other most likely thing that's going to happen is that your body builds immunity or tolerance to these things, meaning it will not work anymore. And it will not work anymore because chances are that the bacteria has changed. So you don't want to take antibiotics every day. You only take it when it's necessary. So that's why white blood cells are far less common, because we don't want them all the time. That's no good. We need them only when we need them. Does that make sense now, guys?
Yes.
Okay. So unlike your red blood cells, your white blood cells actually circulate all throughout your blood. They circulate all throughout your blood because what they're doing is they're hunting. So they actually, when they're triggered, like I told you, my tonsils swell up, that means, uh-oh, there's something that maybe it's pollen, maybe viruses, whatever, entered into my nose or my mouth. So those white blood cells get sent to the site of infection via the bloodstream, and they're there to hunt. Okay, so white blood cells are very different than red blood cells. there are different types of white blood cells, and I'm going to pause there because there's a lot of different white blood cells I want to talk about. So we lump them as the granular leukocytes, which you can see there's 3, which I'll talk about next time. And there are what we call the agranular leukocytes, which we'll talk about next time. But I'll pause there because white blood cells are kind of the star of the show. So I'll have more to say, and I'll show you guys some animations of how they work specifically to protect us. Okay, so we'll pause there. I'm going to stop sharing my screen. Before I pause, what questions do you guys have for me about what we talked about today?
Does our immune system have anything to do with like nutrition?
It absolutely does, Scarlett, because so we know what vitamins and minerals are because we talked about vitamins and minerals when we were in the digestive system. But the vitamins and minerals that you take, what they help your body to do is to create those cells. So like they tell you, take vitamin C. It helps to, it helps your immune system. That's true to an extent. I mean, vitamin C tablets are not antibodies, and they're definitely not white blood cells. But what they do is they help your own cells. They're stem cells, actually. It helps your own cells to further along that process of creating those cells. And more importantly, what vitamins do, guys, is they maintain a certain level of balance for those essential nutrients and vitamins that you need to maintain homeostasis. And like we remember, one system depends on the other system, depends on the other system. So in this case, Scarlett, to your question, the digestive system, which is how you take vitamins, that's nutrition. It helps the immune system because you're taking in the things you need to help protect you. So yes, your diet has a huge part to do with immunity. But there's other things. What else do you think helps to support your immune system, guys? Good question, Scarlett. What else do you think helps to support your immune system besides food?
Exercise.
Yeah, exercise, right? That's why you're in PE classes, because when you exercise, what you're doing is a couple of things, right? You're helping your respiratory system to get rid of waste. You're helping your muscles, your muscular system, to transport oxygen throughout your muscles to power the muscles, but also to help rid toxins of your body using lymphatic system. So do we see how all these systems work together, guys? It's fascinating.
Yeah.
It's fascinating. So I'm going to pause there because, again, white blood cells are the star of this show. And on Friday, what I'll do is I'll get into those different types of white blood cells, and I'm going to show you guys animations of each on how they work. Sound like a plan?
Yeah.
Okay, and thank you all you guys that submitted your projects. I graded most of them and I gave you guys feedback. So we're on our last module, guys. So please go ahead and get started on the last bit of assignments. You only have about 4 more to go, I think. I think it's only 4. So you're in the home stretch, y'all. So thank you so much for your hard work. And again, congratulations, seniors. Daisy, you came in a little late, but whoop, whoop. I saw, well, actually, I made that PowerPoint for you, Daisy. So I know exactly what you won. But congratulations, okay, guys?
Thank you.
All right. Bye, y'all. I'll see you guys on Friday, okay?
Bye.
Bye.